Question 33. Which of the following function is even function? Even function, the power is odd, it is odd function. Number over even power will be even. Number over odd power will be odd. If we did simplification, x cubed will be an odd function, so answer is going to be B. Question 34. Which of the following function is symmetric with respect to origin? Being symmetric with respect to origin is the case of having an odd function. It is the property of odd function. 2 over x plus 7 is none of them. Even over, neither is neither. Number is even and denominator is also even, so function will be even. Numerator is odd, denominator is even, so division of odd to even is odd. Numerator is odd, denominator is none of them, so it will be none of them. We were looking for odd function, so answer is going to be C. 35. Which of the following is symmetric with respect to origin? Again, our question is about finding odd function. I have a number and even power, so numerator is even, denominator is also even, so it will be an even function. Odd and even, their addition doesn't make any sense. Neither over even is again will be none of them. X squared is even, x is odd, number is even, so it is neither over neither. Numerator is odd, denominator is even, so even over odd will be an odd function. Answer is D. Question 36. Which of the following is a false statement? And if we look at each statement, we are looking for odd function. What was the property of odd function? Odd function has to satisfy this equation. F of negative x should be equal to negative f of x. So if we write negative x, negative root of x, can we do any simplification? Is it equal to function itself? No. Can we take minus sign out? No. So it is actually none of them. And if we remember the graph of root of x, you are going to see there is no symmetry. So it is not an odd function, it is one of the false statements. Cube root of x. If we plug negative x, because of odd degree, minus can be taken outside. So we can see the property of odd function, minus in the beginning can be taken outside. So it is okay with the property of odd function. So it is a true statement. Fifth root of x, if we write again negative x, because of odd degree, minus can be taken outside. It is also satisfying the equation in the beginning, which is the property of odd function. So statement 3 is, where is it? Statement 3 is also a true case. The question was asking the false statement. Only A, only the first one is the, where is it? Only first one is false statement. 37. Which of the following is symmetric with respect to y? Symmetric with respect to y. Symmetry with respect to y is property of an even function. And if you pay attention, number and x squared will be chosen as an even. X is odd, even over odd is odd. I can give a hint like this. Even function can be thought as a positive sign, and odd function can be thought as a negative sign. So some division of them, multiplication of them will be always negative. X is itself odd. X squared plus 2 is even. Even over odd is also odd. And if you pay attention, I have all even powers and number, they are all even. So even plus even becomes even. And 1 is actually even. Root of x, none of them, so there won't be any answer here. We were looking for the even statement, which is C. Question 38. Which of the following is not symmetric with respect to y? Being symmetric with respect to y is the condition of even function. So actually the question is, which of the following function is not even? Absolute, and don't forget the property. We have a property like this. The absolute value of negative x, it cannot be taken outside, but at least we know that it is equal to absolute value of x. So it is an even function. X squared is even, x to the power of 5 is odd. Even and odd, addition is none of them. X to the power of 4 is even, x squared is also even. The absolute value of even function is even. X cubed is odd, x is odd. Sum of them is again an odd function, but absolute value of odd function becomes even. So which of the following is not an even function? Answer is B. Question 39. Which of the following is not an odd function? Not an odd function can be the case of neither, I mean none of them. It can be also the case of even function. Don't forget the property of absolute value of x. X is itself odd, and absolute value of x is even, number is even. Even over odd over even becomes odd, and x is itself odd function, odd function, absolute value is even. Even odd over even is also odd. If you pay attention, even plus odd and odd minus even doesn't make any sense. Answer is going to be C. Question 40. Which of the following is true? Cosine is even function. Yes, exactly. It is a true statement. Tangent is, since it is division of sine to cosine, ratio of sine to cosine. Sine is always odd. Sine is always odd. So odd over even will be odd. So tangent cannot be even function. Only the true case is first one, which is A. Sorry. Question 41. Which of the following function is not an odd function? Not an odd function. I can think similar. I can look for the case which is neither, and I can also look for the case even. Sin x is an odd function. 1 over x is also odd function. Sum of them will be another odd function. Sine is itself odd, cosine itself even. Odd over even becomes odd. 1 is number will be chosen always even. Cosine is even. Sum of them even. Over odd, which is odd. 1 minus cosine squared, it is even, and cosine squared is also even. Even minus even is even. So answer is going to be D. Question 42. Which of the following function is not even? Not even can be the case of neither, and not even can be also the case of odd function. Let's have a look for each choices. In the choice A, there is even function in numerator, even function in denominator, so division of them is even, so it cannot be the answer. Cosine is even, numerator is even, x squared is even, cosine is also even, so even over even is another even function. Before deciding, I have to be careful here. What I am going to do, normally even function has a property like this: f of negative x should be equal to negative f of x. So let me write negative x for each x that I see in the expression. Negative x plus 1 minus negative x minus 1. Of course, to decide, I have to do some arrangement, some simplification. Negative x To use the property which I mentioned in the question 38, absolute value of negative x is equal to absolute value of x. So let me see something here. What do I mean? Instead of negative x plus 1, I can write negative of x minus 1 in absolute value. Minus the absolute value of, since x has minus sign, so minus can be taken outside, x plus 1 by using the property that I mentioned. The minus can be removed because of absolute value, so this expression can be taken as absolute value of x minus 1, and this is also same, the minus can be removed, so it can be same as the absolute value of x plus 1. We have minus between them. Let's go on. There is negative x in numerator, and the denominator is the absolute value of x minus 1 minus absolute value of x plus 1. We are always going to compare the function that we have in the end with the original one. In the original one, x plus 1 is the first term, but here x plus 1 is in the second. So if I take this minus as a common factor, let me choose a color. Because of having minus in front of x plus 1, I prefer taking this minus in front. So denominator becomes the absolute value of x plus 1 minus the absolute value of x minus 1. In numerator we have already negative x, so if we pay attention, minus over minus becomes plus. The last expression that I have, x over the absolute value of x plus 1 minus absolute value of x minus 1, which is same as the function itself, so it is also an even function. Answer is going to be D.